So in this lecture, we're going to talk about linear inequalities. And a lot of times the procedure is pretty similar to solving linear equalities, but we're just going to have to adjust. Okay, so graph the solution set for each of the following linear inequalities. So let's say that we have 2x minus 3y has to be strictly greater than -6. Okay, so let's say that this was a linear equation. Okay, how would you proceed to graph that? Well, you would solve for y, right, to get y equals mx plus b, and then you would plot that on here. The procedure is actually pretty much the same as that, and we will see how we're going to adjust for this in just a second. So proceed as if you were solving for that. All right, we're just going to solve for y. All right, so solve for first, isolate y on one side, say the left side. Okay, so let's do that. So how do we proceed? So 2x minus 3y greater than -6. Okay, so we will subtract the 2x to both sides. We'll have -3y greater than -2x minus 6. And then now we have to divide both sides by -3. Okay, now thinking back to inequalities, we have to be very careful, right? We're dividing by a negative, so we're going to have to swap this inequality. So we actually will have y is less than, right? Since we're dividing by a negative, what? So -2x over -3 minus 6 over -3. And you could simplify this, so y is less than 2/3 x, and then this negative becomes a plus, so that'll be plus 2. Okay, so that is y isolated, but we need to graph the solution set, right? So there's going to be many values that satisfy this inequality, and we want to plot that in some way. So what we're going to do is first sort of figure out the boundary equation in a sense. All right, so if this was an equation, so first graph y equals 2/3 x plus 2 with a dotted line. Since this is not less than or equal to, but strictly less than, we're going to reserve that for a dotted, we're going to denote that on the graph with a dotted line. So we'll dot it like this. Okay, when we're allowed to have equality, we'll use a solid line instead. Okay, so how do we do that? Well, here's the slope, that's m, and here's the intercept, b. Okay, so the intercept is at 2. So if this is 1 and this is +1, +2, that will be our point right there. Okay, and now the slope is 2/3. So it's a positive slope, right? So we're going to rise 2 and run by 3. So the next point will be right here. And connect, oh, sorry, we're supposed to be using dots, right? Dotted lines. So dotting this line and continuing, right? That would continue forever. And dotting this direction. Okay, so we get that line. Now, we are trying to graph the entire solution set here. Okay, so what do we have as our isolated y? Well, y is less than 2/3 x plus 2. So here is that line, y equals 2/3 x plus 2. So anything below this line, since we're talking about y values less than what is on this line, we actually are talking about any point that's down here. So this is sort of our shaded area. Okay, anything that is less than that dotted line. Okay, so the shaded region is the solution set to that linear inequality. So shaded region is the solution set. Okay. Hopefully that's kind of clear that if you isolate y like this, if this is where y is equal to 2/3 x plus 2, what is below it would be y is less than it. And if you wanted y is greater than it, you would shade in the stuff above. If you're ever worried, you can pick a test point in the region and see that it satisfies the inequality. So for example, the origin 0, 0 is in this shaded region. And is that a solution to this? Well, if y is 0 and x is 0, then you'd have 0 is less than 2. And certainly that is true. So it looks like we have the correct shaded region. So let's just implement the same procedure as we just did to this one here. Okay, so let's isolate the y. So we have negative x plus 2y greater than negative 4. So we will add the x to both sides of the inequality, and we'll have 2y is greater than x minus 4. Then we will divide both sides by the 2. And so we have y is greater than 1/2 x, and then minus 4 over 2. So y is greater than 1/2 x minus 2. Okay, so then are we going to use a dotted or dashed line or a solid line? So we will, since this is greater than but not greater than or equal to, use a dotted or dashed line for y equals 1/2 x minus 2. So again, that's the slope m. This is b. We know how to plot linear equations, so we'll plot that. So b is negative 2. So if this is negative 1 and this is negative 2, then there is our y-intercept, right, at 0, negative 2. So how do we use the slope information? Well, it's positive 1/2, so that is a rise of 1 and positive 1 and a run of positive 2. Okay, so we're using a dotted line, so we will go through this point, but that point is actually not going to be included, right? Because this is y is strictly greater than, okay? So those points are just to help us figure out the boundary of the solution set. Okay, so none of the points on that line are solutions to this, right? But nonetheless, finding this is very helpful because now we know that we're going to consider the points y that are greater than what's on that line. So it's just going to be the region that we have up above here. So this shaded in region here is the solution set. Okay, so the shaded region is the solution set. Okay. For this next example, we have 4x minus 2y is less than or equal to 8. So we're going to follow the same procedure, but already just kind of thinking ahead, because this is allowing for equality, we're going to actually use a solid line when we fill in that boundary linear equation. Okay, but let's isolate the y. Okay, so 4x minus 2y less than or equal to 8. So subtract the 4x over, trying to isolate the y. So you have minus 2y less than or equal to minus 4x plus 8. Divide both sides by negative 2. And remember, dividing by negative, we have to swap this. So this is y is now greater than or equal to negative 4 over negative 2x plus 8 over negative 2. So this is y is greater than or equal to positive 2x and then minus 4. Okay, so thinking of the boundary equation, right? Draw a solid line for y is equal to 2x minus 4, because that anything on that line will be included in the solution set. That's why we want to use a solid line. Okay, so here the slope is 2 and the intercept b is negative 4. So 2, 3, 4, so negative 4. That will be where the boundary line hits the y-axis, and the slope is 2. So the rise is 2, but the run is 1, 2 over 1. Okay, so we're going to go through this point, and we're going to use a solid line. Okay, and then y is going to be greater than or equal to 2x minus 4. So all the y values that are greater than this line will be the ones in this shaded region, and so this will be our solution set. Right, so again, the line is where they're equal. Y is greater than would be above it. Y is less than would be below it. Okay. Using the same technique for this one, really quick. So what do we have? So we can subtract the x to both sides of the inequality. We'll have y is greater than or equal to negative x. So we can use solid line for y is equal to negative x. So what is the slope there? So this tells you m is equal to negative 1 and b is 0, right? The constant term is 0. So that means it's going to go through the origin. And because the y value there is where it's 0, right, on the y-axis. And m is negative 1. So negative 1 slope, the rise is negative 1 and the run is a 1, negative 1 over 1. So it's gonna look like this. Okay, and because it is greater than or equal to, we use a solid line, right? Okay, so solid line, this is gonna be this diagonal here. Okay, and then we want y is greater than or equal to this, so that's going to be up above, right? Greater than or equal to. Okay, so that's the solution set to that linear inequality. Now, let's suppose that I give you some shaded regions, some solutions that are graphed, right? So for each of the graphs shown here, name the linear inequality in 2 variables that is represented by the shaded region. Okay, so since we have a solid line, we know that it's going to either be greater than or equal to or less than or equal to, right? But using the same procedure kind of backwards, what did we do? We always isolated the y. So we're going to have y, right? And the line would be where y is equal to, the mx plus b. But since everything is below, just looking at this, we know that we can start out with y is less than, right? But since this is a solid line, we know that we can actually start with y is less than or equal to, and we just need to figure out what mx plus b is. Okay, so we need to find these, right? The only thing that's unknown at this point is m and b. So again, we're always going to start with y as one of the 4 inequalities that we can have. So since the shaded region is below, we know that it's less than. And since the line is solid, we know that we're going to allow equality there. So we'll have y is less than or equal to. That's how we nail down what one of the 4 possible inequalities is. And then it's going to be a linear inequality, right? So we're going to have mx plus b. So we have to find the slope and the y-intercept. Well, the y-intercept is right here, right? That's at 0, 2. So b is 2. B is equal to 2. And m is the slope, which is the rise over the run. And you can calculate this either by looking at the graph, or you can pick another point, like say this point here, and you could explicitly calculate it. Okay, so the rise is -2, right? So if we calculate it just graphically, what would we have? So let's use blue here, and we'll make this triangle. So you see that the rise putting it in quotation marks because you're going down, but that's still sort of our rise, and that's -2, right? So to go, I'm trying to start from this point to get to this point, go -2, and then your run in the positive, see the rise is going down, that's why it's -2, and to the right that's +4. So you come over here, and that would be -2 over +4, and so then this would be -1/2. Okay, so now we have our two pieces of information that we need, and we can finish the linear inequality up above. So m is -1/2 x, and then b is 2. Okay. Well, what about this example here? So here we will start out with y, okay, and now we're going to write one of the 4 inequalities. So since the shaded region is above the linear equation, right? So the shaded region is above the line, right? So that means it's going to be greater than, and are we going to include the possibility that it's equal to? Well, yes, because this is a solid line, so we'll have greater than or equal to, right? And it's still going to be mx plus b. So you have to find the slope and the intercept. So where does this line hit the y-axis? Well, it hits it right here, right? 0, 0. So that's your b. So b is the y, the y-intercept. Hits the y-axis at y equals 0, so that's b equals 0. And the slope is m, and that is the rise over the run. Okay. Now, again, if you don't, I'm going to solve this a different way, because if you don't like to use the graph itself, you can always pick another point. Say you picked this point here. What are the coordinates for that point? The coordinates are 2, 0. So now that you have the coordinates for 2 points, you could still use the old calculation method. Let's say you want to use the algebraic method versus the graphical one. So y2 minus y1 over x2 minus x1. So what is that if we use these 2 points? So we will have 0 minus 0 from starting here, and then 0 minus 2. So that's just 0 over minus 2, but 0 divided by anything is just 0, right? If you had -2 over 0, that'd be a problem, okay? But this is that's our m, and here's our b. So what do we have? Our linear inequality is y is greater than or equal to 0 x plus 0. So what do we actually have? So this just simplifies to y is greater than or equal to 0. Okay, and if you think about that makes sense, because pick any point in this shaded region, right? Say this one here. So the coordinates are 2, 3, right? Do you see that the y coordinate is always greater than or equal to 0, right? It's non-negative. If you pick anything down here in the non-shaded region, the y coordinate is going to be a negative. Okay, so this does make sense. Well, here's something slightly different. Let's say that we have this shaded region, and we notice already that our line is dashed or dotted, right? So what's going to change here? So we still are going to have y, and then we're going to have one of the 4 inequalities. Okay, the shaded region is below that boundary line. So we definitely know that it's less than. So at this point, it's one of two possibilities, either less than or less than or equal to. Well, this is a dashed line, okay? So that's why it's going to be just a strict less than, not a less than or equal to. Okay, we don't allow equality because it's dashed there. And then we have mx plus b. So we just have to figure out the slope and the intercept. Well, the intercept for that that boundary equation is at positive 2. So b is equal to 2. And what is the slope? So m is the slope, which is the rise of the run. Okay, now again, you could pick another point, but what is the rise? To go from one point to any other point on this line, there is no rise, right? It doesn't go either positive or negative. So the slope is going to be 0, just like it was in the previous one. You see, it's this horizontal line. But if you don't believe me that it's 0 over whatever, which is 0, again, you could pick another point. So this point here is 0, 2, the intercept, and then this point is at 1, 2, right? So if you subtract those two, what do you get? 2 minus 2 over 1 minus 0, so that's 0 over 1, which is 0. So the slope is 0. So then we have y is less than 2, yeah, just less than 2. But substituting in, you have 0x plus 2, so then y is less than 2. Okay, and ask yourself, does that make sense? Well, at any point in the shaded region, say for instance the origin, the y-coordinate is definitely less than 2. Okay, anything up here, the y-coordinate is greater than or equal to 2, including what's on the solid line. So it looks geometrically like it makes sense, picking a few testing points. All right, now in this example, we want to graph the solution set for the following inequalities, which is similar to what we just did up above. So y is greater than negative 3x. So we're not allowing equality, so let's use a dotted line. For y is equal to negative 3x, and that is your slope, and b is 0, right? So b is 0, and the slope is negative 3. So we are going to have a rise of negative 3 and a run of positive 1, right? So the slope, m, is equal to negative 3 over 1. So that is the rise over the run. So the rise will go down 3, and you'll go in the positive 1 direction. And so we will get a line that goes through these 2 points, but it's going to be a dotted line. So let's dot this line. Continue. Okay, and we want to consider y is strictly greater than negative 3x. So all the values that, the shaded region that is above this line. Okay, so that's going to be this shaded region here. Okay, all these y values are above that defining line. Okay, so, or boundary line. Doing the same procedure here. Here we have y is greater than negative 2/3 x plus 3. So here, maybe you could just read this off now. What is m? M is negative 2/3. B is 3. And is this going to be dotted or a solid line? Well, it's not allowing equality, so it's going to be dotted again, right? So B is 3. 1, 2, 3. The slope is negative 2 over 3, so that is the rise of the run. So negative 2 for the rise, go down by 2, but then go in the positive x direction by 3 to get to this point here. And this is a dotted line like we just said. And y is greater than what is on this line, so that is going to be the shaded region that is up here. And finally, for our last example, we have this linear inequality. We need to isolate the y first, so we will subtract the 2x over. We have 3y greater than negative 2x. Divide by 3. We're dividing by a positive, so we do not need to change this. So we have y is greater than negative 2/3 x. This is essentially your m. Your b is 0. So we're going through the origin. Slope is negative 2/3, so the rise is negative 2. The run is positive 3, kind of like the previous example, actually. And this is, again, a dotted line. And what do we have? Y is greater than this, so this is going to be up here.